What we're going to learn in section 3 is something you've already learned in 8th grade called the elimination method. Some textbooks call this the addition method. I've heard it called the elimination method, and I've heard it called the addition method because you do both things in this problem. It just depends who the author of the textbook is. So let's write this down, elimination method. What is it? It's when we add two equations together to get one of the variables to cancel out. The elimination method is where we add two equations together to get one of the variables to cancel out. We want one of the variables to eliminate each other out. One being a positive, the other being a negative. I'm going to give you the easiest example I can give you, and then we'll go from there. This is what it looks like on number 1. Number 1 says x plus y equals 7. X minus y equals 3. X plus y equals 7. X minus y equals 3. The sum of these two numbers is 7. The difference of these two numbers is 3. So what the elimination method is where we add these two equations together. When I put a line like this, what it means is I'm going to just I'm thinking I'm going to add this one with this one, and add this one with this one, and add this one with this one, and bring the equal sign down. So when you do this problem, what we're really doing is x plus x. 1x plus another x is 2x. A positive y and a negative y, when you add them together, makes 0. So I could put plus 0, but I don't have to, because anything added to 0 is going to just be 2x. Like 2x plus 0 is 2x. This, what ended up happening was it eliminated that variable. That's why this is called the elimination method. We are eliminating one of the variables when we add them together. Equals, bring that down. 7 plus 3 is 10. And now what we have is 2x equals 10. 2 times something equals 10. And I bet you a lot of you know what x is going to be equal to. What is it? 5. Exactly. But that is half of your answer. That is not your final answer. If this is half of your answer, just like before, we take this x and plug it into whichever equation you think is easiest. The one with the minus sign or the plus sign, I'd probably go with the one with the plus sign. Instead of x, I can write 5, because I know what that is, plus y equals 7. Bless you. And I bet you most of you know what the y is equal to now. Exactly. But that's not our final answer. That's half of our answer. Our final answer is the ordered pair of these two values, and it is 5, 2. It's a place we could graph. It's a place that has an x and a y. That's called the elimination method. That's the easiest type of problem you can get. When you add them up and they automatically cancel out like that. Okay? So I want to write down some steps because some of these are going to be more complicated. I'm going to put the steps over here, off to the side. Number 1, the first thing that we always are going to try to do is to line up variables and numbers. Line up your variables and numbers. Here's what that means. Line up variables and numbers. I had the x over the x so I could add them up to get to 2x. I have to line them up. Y minus y, they're lined up. The y's are on top of the y's, the equals are on top of equals, the numbers are on top of numbers. That's what we have to make sure it's in that form first before we do anything else. Second thing we do. Sometimes we need to multiply equation, and then I want you to put an S in parentheses, or equations. Sometimes you're doing it once to one equation, sometimes you're doing it to both equations. Multiply equations so that one variable cancels out. We did not have to do that step here. When I added, these two variables canceled out on their own. I got lucky because when I added them up, the y's automatically canceled. That doesn't always happen. Sometimes we have to manipulate it a little bit. Step 3. Add both equations. And I'll abbreviate equations, EQ. Add both equations. Step 4. Solve for the first variable. We found half of our answer when we solved for the first variable. Step 5. Plug in the first variable into the easiest equation. Easiest equation to find the second variable. Plug in the first variable into the easiest equation to find the second variable. Your last step is, since you have half of an answer and half of an answer, to write it as an ordered pair. Write it as an ordered pair, an x, comma, y. If you want to write ordered pair, you can. It's an x, comma, y. So I want to give you an example of some things that don't have it nice and easy. Like the easiest it gets is the one I showed you up here. Number 1. Let's do one that's a little bit harder, like number 5. Not too much harder, just a little bit harder. X minus 3y equals 27. 3x minus 3y equals 39. Let me scoot that over just a little bit. Let you write that down. So now that you have it down, let's go through our steps so you can see what I want you to look for. Step number 1 says, line up the variables and the numbers. Are the x's over the x's, and the y's over the y's, the equal sign over the equal sign, and the numbers over the numbers? So sometimes you have to do this step, sometimes you don't. We don't have to this time. Okay. Multiply equations so that one variable cancels out. Let's look. If I were to add these together, does a variable cancel out for the x's? Now, if I add these together, will the variables cancel out for the y's? No. And so what's going to happen if I add them together right now, something doesn't eliminate. They do not go away. In order for them to cancel out, what we need is we need to get rid of either the x's or the y's. And sometimes getting rid of the x's might be easier, or sometimes getting rid of the y's might be easier. For example, if I want to get rid of the x's, what I can do is multiply by a -3, by a -3, by a -3 to the whole thing, and make this -3x and that a +3x. I could do that. Or, if I look at these two, they would cancel if this was a positive or if that was a positive, right? So I could multiply everything in the top by either a negative or the bottom by a negative. And I choose whatever is the easiest number to multiply by. Do you want to get rid of the x's or the y's? Which one do you want to multiply by, the negative on the top or on the bottom? If you say the top, I would do that too. And the reason why is because this is 27, and if that's negative and that's 39, then I'll have a positive afterwards. That might make life easier. So here's what I'm going to do. I'm going to take this whole top equation, and I'm going to multiply it by a -1. I'm going to put a -1 out front right there. I know it's hard to see that, so let me put it right there. There's -1. And I'm going to multiply everything, this one, and even the 27 by that -1. And I'm going to rewrite it over here to the side of the problem. This becomes -x plus 3y equals -27. I don't have to change the bottom equation. Sometimes you do. This time, we don't. 3x minus 3y equals 39. If we add these together, will one of the variables eliminate or cancel each other out? Yes. Then let's do it. Now that you know how to do it, let's go through this, and I can call on people to tell me what it would be. Right? Like if I said, what is the -x plus 3x, -1x plus 3x? Caleb, what would that be?
2x.
Perfect. Stop right there. Jason, what would 3y minus 3y be?
0.
Perfect. And then Trinity, what would 39 minus 27 be? I agree. And now we have 2x plus 0 equals 12. And that means 2 times something equals 12. I can figure out what x is. Let's go to Melina. Melina, x is 6. If you want to do the math, you divide by 2. And this is half of your answer. Now you have a choice. We've multiplied the equation. We've added both equations. We've solved for the first variable. We have done all these steps. Step 5, plug the first variable into the easiest equation to find the second. So you have a choice. Here's your choices. You can plug this into this equation, the new one you created. You can plug it into this one, or you can plug it even into the original equations. It doesn't matter. You get to pick. This one, or even this one. I don't know which one you want to pick. Jada, which one would you put it into? Oh, this Jaden. I'm sorry, I messed up. The x minus 3y equals 27. She wants to use this one. And so I'll write x minus 3y equals 27. She's going to plug the 6 in there. Now Jada, sorry. Now help me finish solving this, please.
You take away 6 on both sides.
What do you get?
You get 21.
Agreed.
And and then you divide -3 on both sides.
And what do you get?
And you get y equals -7.
Perfect. And then Rachel, this is not our final answer, so what is our final answer?
6, -7.
6, -7. So that is a basic medium level type of problem. Okay? Let's go a little more advanced now. Chase.
Why would you put the -1 in front of
When I originally looked at this problem, if I added, would those cancel out?
No.
If I added those, would those cancel out? So that's the reason. Because something doesn't eliminate, because something doesn't cancel out, I have to multiply by something. I can multiply the first by a negative and this by a negative. If I do, that's going to change this sign into a positive, and then I can get them to add to eliminate. That's the whole goal. I have 2 more examples. This one's a little bit harder, a little more advanced. 3x minus y equals -1. Y equals 3x minus 5. 3x minus y equals -1. Y equals 3x minus 5. Let's look at step 1. Step 1 says, line up your variables and numbers. Do you have x lined up over x? Do you have y lined up over y? Do you have number over number? No. Okay, so if I have x, y, and a number, which is very similar to what I had in the other problems, but I have y equals 3x minus 5, we're going to need to do something to this bottom equation first just to line it up. Should we move this over? Should we subtract 3x from this side to this side? I can do that. I can subtract 3x over here, like that. 3x minus 3x goes away. And now over on this left side, I have negative 3x plus y, because I cannot put those together. Let me write it out just over here, what I get. Negative 3x plus y equals negative 5.
But then if you put them over each other, both of them would cancel out.
Watch what happens. Exactly. This is a more advanced problem, like I said. Okay? The top equation, I'm not going to touch. The bottom equation, I move the 3x over by subtracting the 3x, and I have negative 3x plus y equals negative 5. That's the bottom equation. Now I have done step 1. Step 1. Line up variables and numbers. Now everything's lined up. Sometimes you have to move things around to get them to line up. Now if I add these up, will one of the variables eliminate? Well, I think something's going to eliminate, right? What does 3x minus 3x make?
0.
I'm going to put 0 right there. What does negative y plus y make?
0.
0 plus 0 equals, what does negative 1 plus negative 5 make? So this is what you have. Sometimes things are going to eliminate like this, and you're going to get 0 equals negative 6. If you're saying no solution, you are absolutely correct. There are still possibilities of having no solutions in section 3. I want to remind you something that you wrote down in 4.2 that I'm not going to make you write down here. In 4.2's notes, we wrote down if you ever get a number equals the same number, it was something called infinite solutions. If the variables canceled out and you got a number equals a number, it was infinite. If you got a number equals a different number, if a number is not equal to the same number, it was no solution. Here's what I want you to notice. This variable went away. This variable went away. You don't have a variable to solve. You can't find what x is anymore. You cannot find what y is anymore. Therefore, you just have to check to see these numbers. If they're the same number, it's infinite solutions. If they're different numbers, like this, it's no solution. Last example. I'm looking for it. 8x plus 9y equals 15. Five x minus 2y equals 17. Sometimes the numbers get kind of big, so we'll need a calculator. But here's what are we all lined up?
Yes.
So we don't have to change anything right now. If I add the x's together, will those cancel out? If I add the y's together, will those cancel out? So here's the thing. Earlier I showed you to multiply one equation, but sometimes you're going to have to multiply both equations. If I want this to cancel out, I'm going to have to multiply by something to get to this to 40x and this to negative 40x. Or I'm going to have to get this to 18y and this to 18y. It's the only place where they would match up. It's where they have a common multiple. So here's the thing. Do you want the x's to cancel or the y's? What's easier for you? To get the y's to cancel. We're going to need to multiply something in front of this to make those y's cancel. What number would we multiply by? I'm going to do the 2 on the top. That will make my life a little easier, I think. Because in my head, I'm doing 2 times 9y, and that's 18y. Right? Now, what am I going to have to multiply on bottom to get this to be not 18y, a negative 18y? By 9, right? A positive 9 times a negative 2 would be negative 18. All right, so let's do some math here. I'm going to change the top equation. 2 times 8x is 16x. 2 times 9y is 18y. And 2 times 15, I know that one, is 30. I do the same thing with the 9. 9 times 5x is 45x. Oh, it's big. It's okay. 9 times negative 2 is negative 18y. Wait, 9 times 17. I don't know that one. 153. Will the variables eliminate when we add them now? Now you can continue. Can you do 16x plus 45x? If you don't know, use that calculator. 61x. These eliminate, make 0. I could do this in my head, 183. 61x equals 183. I'm going to divide by 61. I'm going to take 183 divided by, oops, that wasn't divided by 61. It goes in 3 times, which is half your answer. So you get to pick now. Do you want to plug it into this equation? Do you want to plug it into this equation? Do you want to plug it into that equation?
Here's the results.
Okay, thank you.
And a really long letter.
Oh, wonderful.
It's not an email, it's a letter.
Hey, that's okay. Yeah, there you go. Plug in the 3. What's the easiest equation? Probably this one. 8 times 3 plus 9y equals 15. That's 24. I'm going to subtract 24. 15 minus 24, just because my mind's in a weird spot. Negative 9. Equals 9y. Oh, that's good. That's nice and easy. Y is equal to negative 1. My final answer, 3 comma negative 1. I feel like every answer is going to come out to a nice whole number except for maybe 2 of them on your worksheet. Okay? We're going to stop our notes right there.